Hey TechnoStuds, in this video we're going to talk about OSPF configuration. We have quite a bit to still talk about when it comes to OSPF. But what I want to do is I want you to get some hands-on experience to see what it's like to configure this and see what happens on our devices when we configure it, so that way when we jump into some of these concepts, you have a reference point. So what I'm going to do in this video is briefly cover some of the topics that we'll actually be covering more in depth later on. So let's get into OSPF configuration. In this video, we're going to talk about some of the configurations that you will have to do to set up OSPF. And the first thing you're going to have to choose is a process ID. So we're going to talk about the process ID and what is that. Then we'll talk about the network statements and what a network statement is. We'll get into wildcard masks because OSPF uses wildcard masks instead of network masks. We're going to get into OSPF areas and talk about OSPF areas. And then finally, we'll wrap it up by talking about some of the other configurations that some of it we'll discuss more in depth later on. Now, I said multiple times that link state protocols and OSPF are a little more complicated when you're rolling it out on your network, but it actually doesn't have to be. It can start out very simplistic, and it really is just 2 commands. So less than we implemented RIP with. So what the commands are is router OSPF with the process ID, and then the network statement. And we'll do a network address with the wildcard area and area ID. So there's a couple more components in that we'll be discussing. All right, so an example of that is router OSPF 10 and then network 10.0.0.0 space 0.255.255.255 with an area of 0. So these are the example of the commands that we'll be actually putting in on our network. All right, so the one thing that we need to talk about first of all here is this process ID. The process ID is specific to the router, and it really doesn't have much bearing on that router. It just separates out your different instances of OSPF. Well, in this case, we just are going to have one instance. So I can come up with any number, and I just came up with 10, and I can put it in here. And for consistency purpose, I'm going to want to put OSPF 10 on every single router, but it doesn't have to be because it is the process ID. So it's identifying the process or the OSPF instance. If I were to have multiple instances running on this router, then I would use multiple process IDs. So first of all, don't get hung up on that. You don't need to know a lot about it except for just that it's router specific and that we're going to come up with 10 and put it the same on every single router. Then we have the network statement. The network statement does 2 things for us. First of all, it identifies which networks are going to participate in the OSPF process, meaning that if there's a directly attached network, if that is going to be advertised out or not. The other thing that it does, it identifies interfaces that are going to participate in this OSPF process. So which interfaces are going to send and receive OSPF updates. So what we've done here with this one right here is we've said almost all of our networks that we've specified within our topology really fall under this 10.0.0.0/24 or /8 network. And so we pretty much said that all interfaces and all networks are going to participate. We will get more into the network statement, take a deeper dive later on, but for now, just know that that's what the network statement does. And here's just an example of all of our interfaces and all of the networks do in fact fall under this 10.0.0.0/8. Then we have the wildcard mask. Really what the wildcard mask is very similar to the subnet mask, but it just is the reverse of the subnet mask most of the time. So what I mean by that is the subnet mask, this 255, ends up being all ones. And it says that each one of those bits is a network bit. And all of these zeros are host bits. And so all it's doing is it's saying this is the network and these are going to specify the hosts on that network. Well, wildcard mask, generally speaking, is the opposite of a subnet mask. And so where you have a 255 in the subnet mask, you have a 0 in the wildcard mask, and it's all zeros. And then the rest of this is what it's specifying is those are wildcards. It doesn't matter if that's a 1 or a 0, you're going to ignore those bits. So this right here says all of the last 24 bits of this number, of this IP address, are going to be ignored. We don't care if it's a 1 or a 0. That's the wildcard part of this. So what you end up with is 0.255.255.255 if you're doing a /8. So here is where we've entered in the 0.255.255.255. The last thing that we'll touch on is that OSPF areas allow us to break up our topology into smaller sections. With all of this traffic that's being sent back and forth, with all of these updates that are being sent back and forth, it really can swamp down your network. And the bigger your network is, the more problematic that can be. And so OSPF areas allows us to break it into smaller sections. Well, what the best practice is when you only have one area, which is what we're going to have on our network, then that area should be area 0. So for our area ID, for the purpose of most of this class, most of this course, we're going to be using area 0. Now, we don't need to get into a lot of the other configurations for us to at least just initially set something up, but I thought I would mention them because we are going to get into them later on. And one of them is going to be the OSPF hello intervals. We'll get more in depth into that. We'll talk about a passive interface and what a passive interface does. We're going to talk about how we can manipulate OSPF costs, because we're definitely going to want to do that when it comes to OSPF. We're going to talk about OSPF priorities, and we're going to get into OSPF router IDs. So there you have it. We really just covered the basics so we could get our OSPF network up and running. And the basics are the process ID, which really doesn't have much significance at all. We're just going to come up with 10. We're going to be consistent across all of our routers, but since it's router specific, we wouldn't even need to do that. Then we talked about OSPF networks and how we're specifying both the networks that are going to be sent out to other devices, but also specifying the interfaces that are going to send and receive OSPF messages. We talked about the wildcard mask, and for the purposes of what we have now, it's pretty much whatever the opposite is of the subnet mask to specify a range of addresses. We talked about OSPF areas and how bigger networks will need to break it into smaller networks, but since we have just one single small network, we're just going to use area 0. Best practices is to use area 0. And then we talked about a few other configurations that we will get more in depth into in later videos.